Meditation triggers a cascade of profound neurobiological changes that transform both brain structure and function. Research using advanced neuroimaging techniques reveals that meditation literally reshapes your brain, altering neurotransmitter levels, brainwave patterns, and neural connectivity in ways that promote mental well-being and cognitive enhancement. When you meditate, your brain undergoes significant neurochemical shifts that promote relaxation and positive mood states. Meditation increases levels of key neurotransmitters that regulate emotional well-being. Dopamine, associated with pleasure and reward, serotonin, linked to happiness and mood stability, and GABA, responsible for calmness, all rise in response to meditation practice. These neurochemical changes create a more positive, relaxed, and contented mental state. Studies of transcendental meditation practitioners show elevated serotonin breakdown products in urine samples, indicating increased serotonin activity both before and especially after meditation sessions. Research also demonstrates that meditators have lower levels of norepinephrine, a neurotransmitter associated with anxiety and stress responses. This reduction in norepinephrine correlates with decreased anxiety levels and improved emotional regulation. Meditation fundamentally changes the electrical activity patterns in your brain. The practice shifts brain activity from high-alert, fast brain waves associated with stress and hypervigilance to slower, more relaxed wave patterns linked to states of calm, deep focus, and restorative sleep. One of the most remarkable findings is the dramatic increase in gamma waves, 30 to 100 Hz, in experienced meditators. Gamma waves represent the fastest brainwave frequency and are associated with heightened mental clarity, peak cognitive performance, and states of expanded awareness. Long-term meditators show significantly higher gamma activity in parieto-occipital brain regions, with this increased gamma power directly correlating with years of meditation experience. This gamma enhancement appears as both a state effect during meditation and a trait effect, even when not meditating. Meditation induces neuroplasticity, the brain's ability to reorganize and form new neural connections. Structural MRI studies consistently show increased gray matter density in brain regions critical for higher-order cognitive functions. Attention and focus, increased gray matter in the anterior cingulate cortex and prefrontal regions. Emotional regulation, enhanced volume in the hippocampus and orbitofrontal cortex. Self-awareness, greater density in the precuneus and superior parietal regions. Sensory processing, increased gray matter in sensory cortices. Remarkably brief meditation interventions can produce structural changes. Studies show that as little as 10 hours of mindfulness training over 2-4 weeks can increase gray matter volume in key brain regions. Even more impressive, 6 months of daily meditation can increase gray matter in patients with mild cognitive impairment and early Alzheimer's disease, suggesting meditation's neuroprotective effects. Meditation uniquely develops the brain's white matter, the fiber optic cables that connect different brain regions. Unlike skills that typically enhance specific brain areas, meditation strengthens the communication pathways between regions. The corpus callosum, which connects the brain's left and right hemispheres, shows increased size and density after just 4 weeks of mindfulness training. This enhanced connectivity enables better integration of brain functions and may explain meditation's effects on emotional regulation and cognitive flexibility. One of meditation's most significant effects involves the amygdala, the brain's alarm system responsible for triggering fight or flight responses. Experienced meditators consistently show smaller amygdala volumes compared to non-meditators. More importantly, longitudinal studies demonstrate that just 8 weeks of meditation training can measurably shrink the amygdala. This structural reduction corresponds with functional changes. Meditation training alters amygdala connectivity patterns, particularly reducing its coupling with the subgenual anterior cingulate cortex, a pathway associated with stress reactivity. These changes appear to create a less reactive stress response system, enabling meditators to maintain greater emotional equilibrium during challenging situations. The default mode network, DMN, consists of brain regions active during rest and self-referential thinking, including mind-wandering, rumination, and autobiographical memory. Hyperactivity in the DMN is associated with depression, anxiety, and unhappiness. Meditation practice consistently reduces DMN activity across all forms of meditation, concentration, loving kindness, and open awareness practices. The primary DMN nodes, posterior cingulate cortex and medial prefrontal cortex, show decreased activation in experienced meditators. This reduction correlates with decreased mind wandering and increased present moment awareness. Paradoxically, while reducing overall DMN activity, meditation can also enhance functional connectivity within specific DMN regions, particularly between the posterior cingulate cortex and rostrolateral prefrontal cortex. This increased connectivity is associated with improved attentional orienting and metacognitive awareness. Meditation strengthens brain networks involved in attention control and executive function. The anterior cingulate cortex, consistently identified as a key region affected by meditation, shows both increased activity and structural changes. This region is crucial for focused attention, conflict monitoring, and cognitive control. Experienced meditators demonstrate enhanced activation in the dorsolateral prefrontal cortex and anterior cingulate cortex during attention-demanding tasks. These regions work together to maintain sustained attention and regulate emotional responses, explaining meditation's benefits for focus and emotional stability. Meditation appears to slow age-related brain changes. Studies comparing meditators with non-meditators by age found that the cortical thickness of 40, 50-year-old meditators resembled that of non-meditators aged 20, 30 years. On average, meditators' brains appear approximately 7 years younger than those of non-meditators. This neuroprotective effect extends beyond general brain preservation. Meditation practice specifically counteracts age-related decline in the putamen, a brain region involved in learning and attention. Long-term practitioners show slower gray matter volume loss in multiple brain regions compared to age-matched controls. Recent research reveals that meditation enhances large-scale brain network integration. After just 1 month of mindfulness practice, brain scans show increased connectivity between major networks, including the default mode network, salience network, and central executive network. This enhanced internetwork communication may underlie meditation's wide-ranging cognitive and emotional benefits. The salience network, which helps direct attention to relevant internal and external stimuli, shows particularly robust changes with meditation training. Enhanced salience network function may explain meditators' improved ability to recognize when their minds have wandered and redirect attention to the present moment. The neuroscience of meditation reveals that this ancient practice produces measurable positive changes throughout the brain, from increasing beneficial neurotransmitters and enhancing gamma brainwaves to literally reshaping brain structure and improving network connectivity. Meditation acts as a comprehensive neural fitness program. These changes explain meditation's documented benefits for stress reduction, emotional regulation, attention enhancement, and overall mental well-being. The remarkable finding that even brief meditation training can produce neuroplastic changes suggests that the brain's capacity for positive transformation through contemplative practice is both profound and accessible. Advanced neuroimaging has validated what contemplatives have known for millennia. Meditation is a powerful tool for optimizing brain function and promoting psychological well-being. Whether you're seeking stress relief, improved focus, emotional balance, or cognitive enhancement, meditation offers a scientifically validated path to brain optimization. The benefits begin with your very first session, as your brain starts adapting to this powerful practice. With consistent practice, these neurobiological changes compound, creating lasting improvements in mental function and emotional resilience. As neuroscience continues to unveil meditation's mechanisms, we're discovering that this ancient practice represents one of the most effective methods for enhancing human cognitive potential and emotional well-being. Your brain is waiting to be transformed. The question isn't whether meditation will change your brain. The science proves it will. The question is, when will you begin? Join millions of practitioners worldwide who have discovered meditation's power to optimize brain function, reduce stress, and enhance overall quality of life through the remarkable neuroplasticity of the human brain. Your journey to a healthier, more resilient brain begins with a single breath. Start today and let neuroscience guide you toward your brain's highest potential.